Okay, Unit 6, Lesson 15.2, constructing geometric sequence. Constructing that make. You're going to make a sequence, right? Make a sequence, geometric. Okay, first one, complete. Okay, below are the first 5 terms of a geometric sequence. 1, 2, 3, 4, 5. 5 terms. Yeah, the first 5. So that means there's still more, right? There's still more. What is n? N is the position number. It's the order, right? The order, the position number. That means the first one, the first position, the second position, third, right? Position number. For example, if, okay, f of n, that means the term, right? The value of that term. So if I write out this sequence like 3, 12, 48, 192, 768. Okay, this is n equal to 1. The position is 1. This is the n equal to 2, position 2. This is the position 3, position 4, position 5. Basically, n means the position number, the first term, second, third, fourth, fifth, right? F of n is the value. So the first term, I can also write f of 1. I replace n by 1, because that means the sequence value at position 1, right? Which means the first term. So the first term, the value is 3. The second term, value is 12. The fifth term, the value is 48. Blah, blah, blah. Keep going. Okay. The general rule. We'll talk about this later. Okay. Let's fill up the table. Okay. Filling the bottom row by writing each term as the product. Product, that means something multiply something equal to the product. When you see the word in math, product, that means the result, the answer of a multiplication. We have to write it as the product of the first term. Okay, the first term. What is the first term? The first term is 3. And a power of the common ratio. Okay, the common ratio. What's the common ratio? So 3 multiplied what equal to 12? Multiplied by 4, right? 12 multiplied by 4 is 48. 48 multiplied by 4 must equal to 192. So the common ratio, okay, I'm going to write out the common ratio. The common ratio equal to 4. So we're going to write each term as a product of first term and multiply. Multiply by what? Multiply by the common ratio is 4. What's the position? What's the power? 3. 3 multiply what equal to 3? Multiply 1 equal to 3. But look at, I have 4. 3 times 4, that's 12. How do I change the 4 to 1? So the power must be 0. Any number, like 7 raised to the 0 power is 1. 2 equal to raised to the 0 power is also 1. So any number, I'm going to use A represent any number. Any number raised to the 0 power is always 1. There's a reason for that. There's a mathematical, logical reason for this, but we don't have time to explain it here. Okay, the second term. The second term is 12. 12, I rewrite as a product of the first term. First term is 3. Okay, let me copy the first term for every cell, right? Raised to the power of the common ratio. The common ratio is 4. So 3 multiplied by 4. When we see a number and another number, here's a parenthesis. That means this number multiply the second number, right? I better put the second number in the parenthesis. Otherwise, they will be 64. Oh, that's 34, right? Sometimes we can write 3 times 4. This and this, they're the same thing. Yeah. Or sometimes we put both parentheses. This is also means 3 times 4. Do you have to put a parenthesis on both numbers? No. Normally, we use parenthesis for the second number. So that means 3 times 4. 3 times 4 equal to 12. So the power of 4 must be 1. Then the next one, 48. 48 raised to the second power. 4 raised to the second power. That means 4 times 4. That's 16. 16 keep multiply by 3. That is 48. Yeah? So the first one, 3 times 1. The second one, 3 times 4. And then the third one, in fact, 3 times 4 raised to the second power. I mean 3 times 4 times 4. Yeah? Multiply each term by 4. To keep multiplying by 4. 192. So this power must be 3. Power must be 4. So that's it. That's it for the table. First term, common ratio raised to the power 0. That means you haven't multiplied yet. So 0 power. So just the general rule is the first term multiplied by the common ratio, which is 4, raised to what power? Look at the power here. The power is always 1 less than the position number. Look at, here's 0. The power is 0, but the position is 1. The n is 1. Yeah? Then look at this term. The power is 1, but the position is 2. It's always 1 less. So when we write out the rule for every term, we need to put the power equal to the position number and then minus 1. The 1 less than the position number. So this is the rule to create the specific sequence like this one. Okay, just remember that this is the rule of geometric sequence, or we call the formula of the geometric sequence. The form, yeah? First term, common ratio raised to the n minus 1 power. So every sequence can be different. All you need to do is change this number, the first term, change the common ratio according to your sequence, and the power n minus 1. So that's it. Okay, let's do the rest of the question. Each rule represents a geometric sequence. Okay, keep multiplying. Okay, the common ratio for this one is 2. First term is 11. Okay. If the given rule is recursive, write it as an explicit rule. If the rule is explicit, write the recursive. Okay, what's the difference between recursive rule and the explicit rule? Explicit rule, you can use that rule to figure out any position, any term. But the recursive rule, you always have to know the previous term to find the next term. So explicit rule is way more important, way better. Okay. This rule we just did for the first question is a recursive rule. No, sorry, explicit rule. The recursive rule is you always have to write out the first term. Okay, so this is the explicit rule. The recursive rule, first term is 11. And then any term equal to the previous term. The previous term, that means the position is one less. It's before, right? Because this number is smaller than this. So this position is smaller than this position. So any term equal to the previous term and then multiply by common ratio. Or you can write R common ratio times the previous term. This is a recursive rule. Honestly, we don't use a recursive rule for geometric sequence because it's not as good. For arithmetic, sometimes we use this kind of rule a lot, but honestly, this is way more important. Okay, number 3. Number 3, look at first term. When you see, okay, they list out the first term. And then this is the rule, the previous term times the common ratio. This is the recursive rule for n greater than 2. Okay, I forgot this part. N greater than or equal to 2. Okay. That's my second question. Okay. Recursive rule. Number 3, recursive rule. I need to change it to explicit rule. Okay, explicit rule tells me I need to use the common ratio first. So common ratio is the multiplier, right? The previous term multiply. So this is a multiplier. So 3.5 equal to, oh, sorry, I need to put the first term first. So the first term multiply by the common ratio raised to the power of n minus 1. So that's it. Number 4. Oh, we see the first term and then another rule. Oh, this is a recursive. We need to change it to explicit. So f of n equal to first term, 27, multiplied by multiplier. The multiplier is 1/3. So multiplier is 1/3. In fact, this one is divided by 3, right? So 1/3 raised to the power of n minus 1. Sometimes you will see some book, the power, they also put a parenthesis. But you don't have to, because n minus 1 is the power, yeah. It's raised above the common ratio. And here we don't have any multiplication, any other stuff. So you don't have to use the parenthesis. Number 5. Number 5. Oh, very simple, yeah. Just one little equation, one little rule, formula. So that means this is an explicit rule. Now I have to separate. Let me figure out the first term. First term is just this number, yeah? Because of the first term with n equal to 1. So 1 minus 1 is 0. So 0.5 raised to the 0 power is just 1. So this part is 1. 1 times negative 4 is still negative 4, right? So that's why I said the first term is just the first number before the previously than the previously of the common ratio 0.5. Okay, now I need to write out the second equation. So any term equal to the previous term multiply the common ratio. The common ratio is 0.5. And then I have to write, okay, for for n greater than or equal to 2. I run out of room. So put it at the end. Okay. This is number 5. Number 6. Let's try number 6. Write an explicit rule for each geometric sequence based on the given term from the sequence. Assume that the common ratio r is positive. Okay, r is positive. So number 6, geometric sequence. Okay, the first term is 90. So a is sub 2, so a sub 1. A means the term number, right? The term is a number. And the sub a, the little 1 right here, that means the position 1. So here means position 2. That means the first term and the second term is another way to represent so a sub 1, a sub 2, and that's another way to represent the geometric sequence. First term 90, second term 360. Ooh. Only give the first 2 terms, right? Okay, we need to figure out the common ratio. So 90 multiplied by what equal to 36? So 9 times 4. Okay, this is multiplied by 4. 90 times 4, 360. So the common ratio is 4. Now I can write out the formula. F of n, that means any term in the sequence equal to the first term. Okay, first term is 90. Multiplied by the common ratio. Oh, I should write 4. The common ratio raised to the n minus 1 power. So that's it. All you need is to figure out the first term is given, right? You figure out that the common ratio is 4. It's a multiplier. The multiplier is 4. So that's it. Put them together. Put them in this form. So that's it. Number 7. 16. The first term is 16. So 16. So this is the first term. Oh, this is third term. Oh, we don't know the second term. And we know the third term is 4. That means 16. Oh, because the number is getting smaller. So I'm going to divide, right? You can divide. Divide by what? And I'm thinking, divided by 2? Let me try 2. So 16 divided by 2, that's 8. 8 divided by 2, that's 4. Oh, the common ratio is dividing by 2. But I need to change it to multiply. Divided by 2, that's just equal to multiply by 1/2. So the common ratio is 1/2. So that means 16 multiply 1/2 equal to 8. 8 multiply 1/2 equal to 4. Half of each number, you got the next one number, right? Half of 16 is 8. Half of 8 equal to 4. So the common ratio is 1/2. Now I can put in the formula. First term, 16. Common ratio, half, raised to the n minus 1 power. That's it. It's a little tricky. Look at this one. First term is 2. First term is 2. Do I know the... Okay, let me write here. First term and the fifth term. Oh my God, there's a 4 number missing between. So 2, the first term, second, third, 4, and then 162. This one is tricky. The n equal to 1, so this is 1, 2, 3, 4, 5, right? Okay, got it. So 2 multiply something. Let me figure out the common ratio, right? So 2 multiplied by r, multiplied by r, multiplied by r, multiplied by r. So 1, 2, 3, 4. We multiply r by 4 times. 1, 2, 3, 4. So I can rewrite like r raised to the first power. n equal to 162. I need to figure out the r. This one is a little tricky. I will do this for you guys. So r equal to what? Solve for r. R equal to, I'm going to use 162 divided by 2. It's 81. A raised to the first power, because I'm going to get rid of the 2, right? Divide by 2 on both sides, so this become 81. So what number raised to the first power equal to 81? So that is 3. 3 raised to the first power equal to 81. That means 3 times 3 times 3 times 3. This is 3 raised to the first term, right? So 3 times 3 is 9. 9 times another 9 is 81. How do I figure out this question so quick? Because I've been doing this forever, right? So I know 3 raised to the first power equal to 81. So the common ratio for number 8, the common ratio is what? It's a 3, right? It's a 3. Let's double check. So 2 times 3, that is 6. 6 times 3, that's 18. 18 times 3. Okay, 18 times 3, I believe that's 54. Okay. Then 54 times 3, 162. That's correct. So common ratio is 3. Now I can put in the formula. So f of n equal to first term 2 times the common ratio is 3 raised to the power is n minus 1. So that's it, the formula. Any position, any term equal to 6 times 3 raised to the position minus 1 power. Number 9. Oh, number 9. We have the second term and the third term. We don't have the first term. So the first term, and then 30, and then 10. Whoa. So I know 30. 30 divided by, or multiply 1/3. Or I can call as a divide, right? Divide by 3. So 30 divided by 3 equal to 10. Yeah? 30 divided by 3, that's 10. Okay. The different direction. Whoops. Oh, what happened to my iPad? So to go to this direction, that's divided by 3. Go to an opposite direction, so this must be multiplied by 3. Yeah? So 30 multiplied by 3, that's 90. So the first term is 90. So it's 90, 30, and 10. Right? So divided by 3, divided by 3. I changed it to multiplication. That means multiply by 1/3. Multiply by 1/3. Right? So the common ratio is 1/3. Common ratio is 1/3. Okay, let's put everything together as a formula. First term, 90. We figured out first term, 90. Multiply by the common ratio, 1/3 raised to the n minus 1 power. So that's it. So this is the answer. So this is n minus 1, okay? N minus 1. Number 10. It's a word problem. A bank account earns a constant rate of interest each month. The account was opened on March 1st with this. April 1st, the balance in the bank was this. Use this information for 10 to 12. Okay. We know the beginning. Maybe this is the first term, right? And then March, April. Okay, this is the second term. Okay. Write an explicit rule and recursive that can be used to find the balance after n month. Yeah? Okay, what's the common ratio? We know the first term is 18. Oops. The first term is 18,000. And then after 1 month, 18,045. So the common ratio, we're going to use the second term divided by the first term. So 18,045 divided by 18,000. Oh, the common ratio is 401 over 400. This is a fraction. I'm using my calculator. Or 1.0025. Okay, 10. We're going to write out the explicit rule and the recursive rule. Okay, I'm going to use a different color. Okay, recursive rule. F of n equal to first term 18,000 times the common ratio 1.0025. You can use 401 divided by over 400. You can use that too. Okay, done. Recursive rule. No. Explicit. Now we're going to do the recursive. Recursive, we always have to figure out the first term. So the first term is 18,000. And then any term, f of n, that means any term equal to the previous term multiplied by 1.0025. So that's it. I have to put this for n greater than or equal to 2. That's it. Find the balance after 5 months. Okay, after 5 months, that means the 5th. Let me think about it. Because the first month is 18,000 and 1, 2, 3, 4, 5. So this is n equal to 5. 1, 2, 3, 4, 5. Okay, after 5th month, there's 18,000 times 1.0025 raised to the 5 minus 1 power. Yeah, so 18,000 times 1.0025 raised to the power 4. Okay, now I can use a calculator to figure out the final answer. So in your calculator, you're going to calculate this part first. Whenever we have a multiplication involved with exponent, with a power, right? We figure out the value of this part first. And then we multiply 18,000. Okay, I'm using my calculator. 1.0025 raised to the power of 4 is equal to 1.0100. Oh, many digits. Then I'm going to multiply 18,000. So the final answer is 18,1. Okay, let me change. Hello. 18,180.68. Okay, I'm only keep 2 digits after the decimal point. Okay, after 5th month, okay, the 180 should be the interest, huh? Okay, that's it. Find the balance after 5 years. Oh, 5 years. 5 years. 5 years, that's how many months? So each year is 12 months. 12 times 5, that's 60. Oh. After 5 years, that means after 60 months. So this is going to be 18,000 times 1.0025 raised to the power of 60 minus 1. So that is 18,000 times 1.0025 raised to the 59th power. Oh, I have to use calculator. 1.0025 raised to the power of 59. This equal to 1.1587 multiply 18,000. This equal to the final answer I'm going to write down here. 2856.96. Wow, after 5 years, wow, 18,000 become 20,000 something. So that's it for lesson 15.2. I believe this is part 4.